Nobody needs reminding that Australian summers often bring extreme weather. But there's one type of dangerous weather event that's notoriously difficult to predict: the destructive and sudden summer thunderstorm. A group of university researchers has been following storms around Brisbane this summer, trying to learn more about how so-called supercells develop. Peter McCutcheon reports.
Good. It is.
As a storm approaches, the work begins. The sky is darkening over the ranges southwest of Brisbane.
Just working out which way to point the lidar. Once you get the antenna set up, just put it near the store here.
These researchers are racing against time to get their instruments in place.
Judging by it, looks like we're going to get a lot of rain, a lot of wind. At the moment, no hail.
Which is good or bad news?
Good if you got a car park just over there.
A generator is running a special weather laser, or LiDAR, which will be used to measure the wind speed. And a weather balloon is being prepared to gather more data higher up in the atmosphere. It's hoped the information gathered here will help solve a meteorological mystery. Why is it so hard to predict where dangerous summer storms will hit?
When you start having days where storms are moving left, storms are moving right, some storms are moving towards the coast, issuing warnings to the public can be chaos.
Destructive late spring and summer storms are a regular part of life in Queensland and New South Wales. But sometimes these storms can be devastating.
It was terrifying. Absolutely terrifying.
5 years ago, a suburb in Brisbane's west, the Gap, was ripped apart by what appeared to be a smaller cyclone-like storm. It's what meteorologists call a supercell.
Supercells are the strongest sort of thunderstorms, and they require a very specific set of ingredients. The interaction is quite complex actually, but it produces some of the strongest thunderstorms we see on Earth.
Luckily, a supercell of this magnitude is a once-in-a-decade event. But smaller versions of these destructive storms occur up and down the east coast every summer. And predicting where these storms will hit is notoriously complicated.
It's not too difficult to say when a particular day will be favourable for supercells, but once you get into that day, it's very difficult to say which particular areas over the scale of a city like Brisbane will be affected.
Okay. All right. Okay. I'll let it go.
So Joshua Soderholm is looking into the heart of summer storms for answers.
We release weather balloons during the storms as well, and they allow us to profile wind, temperature, pressure and all those variables from the surface up through the cold air mass from the storm all the way to the tropopause, so 14 kilometres.
After taking data from the cell as it first comes off the ranges, Joshua Soderholm and his team attempt to get ahead of the storm as it moves closer to the coast. And this is the key to understanding summer squalls all along the eastern seaboard. What happens when storms coming from the west clash with the coastal sea breezes?
Sydney experiences sea breezes almost in exactly the same fashion as Brisbane. Melbourne also experiences sea breezes off the bay, so all those cities around the east coast of Australia down to the southeast also have a similar setup where sea breezes can either intensify or weaken thunderstorms.
The approaching storm is potentially dangerous.
Before that thing gets here, not too long, maybe about 10 minutes.
And there's a lot of lightning.
Yeah, this one's a bit more electrically active.
The sea breezes have clearly caused the storm cells to dramatically intensify. And although on this occasion it hasn't formed a supercell, it does give researchers an invaluable insight into how dangerous storms can develop. 40 millimetres of rain fell in just 10 minutes, with more than 25,000 lightning strikes.
I was watching it from the building here, and it was one of the more lightning-active storms I've seen over the past few years.
Following storms can be a hit-and-miss affair, and in this case the researchers missed the worst of the lightning strikes.
We got reasonable data, but not the best data, and that's just the way the game works.
But researchers don't always need to be in the eye of the storm. The University of Queensland has a fixed station nearer the coast, which measures wind movements by sending rather annoying acoustic pulses into the atmosphere. And Joshua Soderholm and his team have funding over 2 summers to find out more about the elusive Australian summer storm.
Some days we get a perfect storm front, some days we hardly get anything at all. It's the unpredictable nature of storms.